Welcome to Earth Science Day, everybody. How we doing? It is finally time for seasons. We've been threatening to get there for a while. Here we finally are. Seasons. One thing we disproved already with our elliptical orbit lab was the idea that the sun must be close in summertime. That's why it's hot, and it must be far in wintertime, and that's why it's cold. It's actually the opposite, as we found out. We're close when we're cold, and it's such a negligible amount of difference because the Earth's orbit, although elliptical, is very, very, very round. So that's not it. So what is it? What gives us our seasons? Here's the state standard up here. That's going to tell us exactly what we need to know. Check it out. But let's put that in a little bit more plain English right here. As the Earth spins around the sun, which is you know, one revolution. Remember to keep that straight from rotation. We'll make this a little bigger. As the Earth spins around the sun, which is a revolution, we here on Earth face four different seasons. Why? And really, here's the reason. It all boils down to this. So, star, more colorful star. The Earth's axis is tilted at an angle, and this is another one that's going to be in our head, another number that has to be in our head, 23.5 degrees. That tilts. What it does is it exposes different parts of the Earth to more direct rays or less direct rays. Here, you're leaning in towards the sun a little bit if you are a resident of the Northern Hemisphere. We here in the Northern Hemisphere are leaning in towards the sun a little bit, and that's going to do some things. It makes the sun stay out for a longer time. It makes the sun hit us at a higher angle. The sun's higher in the sky, which more efficiently transfer energy, and it gets warm. Whereas over here in winter, that tilt has the northern hemisphere leaning back, which does all the opposite things. Now the days are going to be shorter. The sun's going to hit at a lower angle, which doesn't as efficiently heat the earth. Therefore, it gets colder. So there's a lot to keep straight here. And again, we're not gonna unpack all of this today. But what I really want to do is two things. We're going to bring up the dates of these things and make sure. And from what I've been able to gather from folks, I don't think this is new. I think you guys have caught on to this pretty well. Once again, the Earth revolves, its axis is tilted. And that tilt is consistent. It doesn't wobble back and forth. Some diagrams make it look like that, but this one's good. It's always tilted 23 and a half, but that tilt during part of our revolution is towards the sun, and during another part of our revolution is away from the sun. Interestingly enough, and borderline hard to believe when you are a rookie in Earth science, there is a star that sits directly above the North Pole here called Polaris, or the North Star. And it has a lot of geographical implications. We'll talk more about it. That is tied in with our system of latitude. It's a very easy one to find. We'll talk about checking it out at night. I saw it this morning, figuring out how to find it. But what's interesting about this revolution, even though we feel from Earth as tiny little inhabitants of this planet that this is a great big revolution, and it certainly is, it's not big enough to have it be any different in terms of pointing towards Polaris. In this diagram, it looks like these are two different stars. In reality, Polaris is so far away, ridiculously far away, that the trip from this side of the orbit to this side of the orbit doesn't mean we're pointing anywhere differently. Our orbit is so small. So no matter what position we're in, the North Pole is pointed right at Polaris. But I would need arrows inconceivably long if I wanted to do this to scale. They're way, 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 way out there. So we always have this tilt of 23 and a half degrees. The Earth revolves around the sun with that tilted axis exposing different parts of the Earth at different times. Let's save that for the next time. That'll be how we warm up. And what I really want to do then, this is going to be like the meat and potatoes of all that we do. All I'm going to do today, this column and this column. And then we're going to move on to the Sun's Path Lab. I just wanted to do a little seasons before you got into that to make sure that we had some footing. So we've got to get down these important dates. I'll show you some tricks to try to remember them. And we have to know the names of them. The spring and the fall one, these are going to be when, think of what spring and fall are. Compared to the extreme of summer and the extreme of winter, spring and fall are when things kind of balance back out again. things become equal again. And if you got that idea down of like things equaling out, that word is going to help you all the way around all of these columns as we have to memorize all this stuff. The spring, equinox, and the fall, equinox. All right, so those will be the days where on the calendar we say first day of spring, first day of fall. That's going to be the day really where on this diagram where we have the technical definition of it is when the sun is going directly overhead at the equator and the earth is like evenly exposed to this daylight and darkness. It's not like a different, like this winter short day long night for the northern hemisphere, the summer long day short night. This is when everything equals back out. So the term equinox kind of handy for that. Summer solstice and winter solstice. I don't know why don't I know the root of that word? I should know the root of that word. It'd be an interesting thing to look up. Maybe you should do that. Why do we call it a solstice? I'm sure it's a Latin root, something like that. But that's good. Those are the 2 days, which again on a calendar we'll say first day of summer, first day of winter. But that's the day where this tilt is most towards the sun, and it's always 23.5 degrees. But it's when it's lined up so that that tilt is boom right at the sun, or when it's exactly away from the sun. Dates. We're gonna have to get these down. Now, for those of you out there that were like me in high school or now, they're not very good at memorizing things. Here's the trick. Here's some things you already know that will help you solve this. Do you know how many months we have? I think you do. Do you know how many seasons we have? You definitely do. So you got 12 and 4. And what's 12 divided by 4? It's 3. So if you can think your way through that process, you really have it, because here's what you're going to do for the important dates. It worked out so that they're 3 months apart: month 3, month 6, month 9, and month 12. So again, take the 12 months, divide them into the 4 seasons, and that's it. The third month, the 6th month, the 9th month, the 12th month, and it works out perfectly. March, June, September, and December are the months with these important dates. Then exactly what date do we have to do? First off, these all can shift by a day or two. So what I'm going to say here is on this one, the 21st. Actually, 3/21 is a better way to say it. 3/21. So March 21st is the date of that. But depending on the year, sometimes it's the 20th, sometimes it's the 22nd, depending on how things fall, calendar, everything else we got. So don't panic too much. And I say, if the regions ask these on multiple choice, they'll only put one like in the low 20s. So if you stick around the low 20s, you're going to be okay. The technical way to do it, if I was being like, aggressive with it, I would say 21st, 21st, 23rd, 21st. So early 20s and you're good, right? It's about in the early 20s of each of those 4 months will be when that celebration takes place. And yeah, that one's on the 23rd. But if you put 9/21 on a test, that's also going to be fine. Don't worry about it. Okay, as long as you're in the early 20s, it'll be good. Now that leaves a whole heck of a lot to do, but we're going to pump the brakes for now. I want to do it a bit at a time, get little nuggets, and then move forward. And of course, there will be classwork, so there will be things to practice all of this. But let's start to get it down, because I'm going to give you another one, and there's more stuff to memorize, and another one, and there's more stuff to memorize, and it's heavy. Sometimes I do this all in one go, and I think it's too much. So we're going bit by bit this year. Okay, so names of those and the dates and the idea that we have these seasons because of the tilts and the revolution will be good. 23.5, also something to stick in the noggin. All right, good job so far. More to come. Good luck.